Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at exponential growth and decay functions. We're going to be looking mainly at how to find the growth rate of an exponential function given a specified model. All right. So the question reads, in the equation a equals p times the quantity 1 plus or minus r to the t, a is the total amount, p is the principal amount, r is the interest rate, and t is the time in years. Question, which statement correctly relates information regarding the annual interest rate for each given equation? Okay, so you're given three models here, and in each model an interest rate is specified. Okay, out of all of this, one of them has a correct interest rate, whereas the other three are incorrect. All right, so let's go ahead and walk through each question. So what we're going to do is we're going to take a look at each model, and we're going to find the interest rate of that model, and then we'll see if it's correct or not. All right, okay, so for question number one, the model is A equals P times the quantity 1.025 to the T. Okay, so something to keep in mind is that whenever this quantity in this parenthesis is a raising to the power, if it's bigger than 1, it's a growth rate. Okay, and if it's less than 1, it's a decay rate. Now, in order for us to find what the rate is, we need to find the rate in decimal form and then convert it to percentage. All right, so notice that this quantity right here is 1 plus or minus r. The rates in decimal form added to 1 or subtracted from 1. Okay, so in order for us to find what the rate is for option 1, we're going to equate this number 1.027 to 1 plus r. Okay, so 1 plus r is equal to 1.0225. Now you might say, oh wait, look at the formula, it's plus or minus. Why did we select plus? We selected plus in this case because it's a growth rate scenario. Even if you take a look at the question, it says increasing. You notice when this 1 plus r component plus or minus r component is bigger than 1, it's increasing. But if it's less than 1, like these two, it's decreasing. All right, okay, so that's why we use plus, because it's greater than 1, which indicates increasing, and exponential growth is plus. You add the growth rate. Okay, if it's a decay, it's subtracted. Okay, so let's solve for r here. To get r by itself in decimal form, you subtract 1 from both sides. Okay, if you do that, it's going to yield the r value in decimal form that we desire, in that r value is 0.025. Now we're going to convert 0.025 to percent. Okay, how do you convert from percent to, how do you convert from decimal to percent? You basically multiply by 100. You can use your calculator to do that, or it's equivalent to moving the decimal points 2 places to the right. All right, multiply by 100 and move the decimal points 2 places to the right will yield exactly the same result. So 0.25 in decimal form, 0.025 in decimal form is the same thing as 2.5%. So for question option 1, you have a 2.5% rate of increase. Okay, all right, so is that in agreement with what's specified? So for option 1, it says the money is increasing at 25%, and working it out, we found out that it's actually increasing at 2.5% using this model. So is that statement correct? The statement is false. Why is it false? It's false because 2.5% is the rate of increase, not 25. All right, now let's move on to the second option. Number 2, option 2, What if we have a situation where the model is A equals P times the quantity 1.0052 to the T? Is the rate of increase was specified here 52%? Well, let's see. So here, the quantity in the parentheses is bigger than 1, so it's going to be 1 plus, again, it's a growth scenario. 1 plus r is equal to this quantity in the parentheses, 1.0052. The same procedure. I'm going to solve for r using algebra. Subtract 1 from both sides of the equation. Okay. When we do that, carry out the subtraction action, we are going to have r is equal to 0.0052. Okay, so now what's the rate of increase? We're going to convert this decimal point into percent. All right, so how do you do that? Two ways: either multiply by 100 or use a shortcut, which is to move the decimal point 2 places to the right. Exactly the same thing. Okay, when we move the decimal point 2 places to the right, we are going to have the percent form of this decimal, which is 0.52%. All right, so we have a 0.52% rate of increase. Now, does that agree with what's specified here? Absolutely not. It says 52%, whereas the correct rate of increase is 0.52. So this statement is false. Why? Because we have 0.52% is the rate of increase. Okay, now let's move on to the third option, question 3. Here you have the amount. We have the model for option 3. The amount is, the model is A equals P times 0.86. All right, this is a decreasing scenario because the quantity, the number in the parentheses that has been raised to T is less than 1, okay? So in this particular situation, we're going to use the decay rate model. Okay, so 1 minus r is equal to 0.86. Okay, we use minus because it's decreasing or decay. All right, to get r by itself, we can just simply, let's just subtract. We can add r to both sides. Okay, add r to both sides and then subtract 0.86. We're doing 2 steps simultaneously. Subtract 0.86. All right. When we do that, we're going to get the final answer. What's the final answer going to be? When we do that, let's see. Get my tool working here. So 1 minus 0.86 is 0.14. 0.14, that adds up to 0. Goodbye. Is equal to, that's also gone to 0, is equal to r. So r is 0.14. So if we convert this to percent, what's it going to be? 0.142%. You just simply move the decimal point 2 places to the right. 1, 2. Bam. Right? Or multiply by 100 is exactly the same thing. 14%. So in this case, you have a 14% rate of what? Decrease. Remember? Because this is a decay model. We're using 1 minus r, so it's a decay situation. Is that what it says here? Absolutely. So option number 3 is the answer to this question. All right. Okay, let's just do the fourth one just to make sure that we are correct. So for option 4, we have the amount equals P times 0.68. This is another decay model. All right, so we're going to use 1 minus r is equal to 0.68. To get r by itself, we're going to add r to both sides. All right, and then subtract 0.68. There are other ways to do this, but I just want to use addition and subtraction operation. All right. Okay, so when we do that, that will give us R isolated completely. All right, so 1 minus 0.68 is 0.32. 0.32, and then that's goodbye. Goodbye. Also, R is 0.32. So that's the decay rate in decimal form, okay? So we're going to convert that to percent. To do that, you either multiply by 100 or use a shortcut, which is to move the decimal point 2 places to the right. All right, so the percent decrease is 32%. So we have 32% as a rate of decrease for number 4. All right, let's look at it. Is that what it says here? Nope. It says 68% is the it means it says 68% is the rate at which the money is decreasing. This is false, 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 false. Why? 32%, okay, is the correct rate, is the rate of decrease. All right, so just something to indicate, I'm just specifying on the side right here. If you have A equals P times 1 plus R to the T, this is exponential growth. All right, just like you have in 1 and 2. On the flip side, if you have 8 equals P times 1 minus R to the T, this is decay. Okay, decay basically means decrease. It's getting smaller, and growth means increase. Just a side point to keep in mind. Alrighty. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. Tons of support resources can be found at mathgotserved.com. If you have any questions or requests, specify it in the comments section below. Thanks again for watching. We'll see you in the next video. Goodbye.